Good day, mathletes! We're now on the first lesson of the first quarter for the school year 2021-2022. At the end of the lesson, we're expected to meet the following most essential learning competencies. Before we begin, let me present to you a video clip entitled "The Beauty Around Us." While watching, observe carefully what is common among them. Observe its images presented and how it relates to our lesson for today. Nothing in nature happens without a reason. All of these have an important reason to exist and gives beauty to our surroundings. Check out examples of some of these. The colored pencil tips and the way we arrange our classroom using bulletin board designs. Different widths of assorted traditional dress and foods like cereal. The leaf paints used for food and water transport around the leaf. And the designs in the brick walls. The uniqueness of our fingerprint and the spider web with rusty leaves. The butterfly collection collected pollen on the flower heads and zebra stripes. Amazing, isn't it? Trees in the forest and the sunflower. See how the florets are arranged in a clockwise and counterclockwise fashion. Can you tell me now what is common among them? Very good. Its images contain patterns. Pattern is a repeated arrangement of images, objects, or numbers. There are many things around us that naturally occurs according to a certain pattern. Pattern can be seen everywhere. Did you know that the butterfly and the moth develop through a process called metamorphosis? This is a Greek word that means transformation or change in shape. There are 4 stages in the metamorphosis or the life cycle of butterflies and moths. Can you guess the missing states? Amazing! It is the pupa stage. What is another term for the pupa of butterflies? Yes, it is called a chrysalis. And it is called cocoon if it is a moth. What about the next image? Nice! It is senior high school. What is the number of the parking spot? If you invert the image, you will find out that the missing number in the parking spot is 87. What about the next term? Correct. The next number is 9. In mathematics, this set of numbers is called a number pattern, or what we call sequence. A sequence is an ordered series of numbers. Sequence are fun because you need to look carefully for clues to guess the next number. Can you describe the pattern in its sequence? We have 1, 3, 5, and 7. Yes, the next term is obtained by adding 2 to the previous term. What about the second set of numbers? 3, 6, 12, 24. Good. The next term is obtained by multiplying 2 to the previous term. Next, 3, 6, 9, 12. What have you noticed? The first term and the pattern are the same. These are multiples of 3. We have 1, 4, 9, 16. Can you guess the next term? Exactly. The answer is 25 because these set of numbers are called perfect squares. Next, 1, 1, 2, 3, 5. What have you noticed? The next term is obtained getting the sum of the two previous terms. Therefore, the next term is 8. That's good because the sum of 3 and 5 is 8. We have negative 11, negative 4, positive 3, and positive 2. What do you think is the pattern? Amazing! The next term is obtained by adding 7 to the previous term. Let's try another one. 5, 10, 15, 20. What's next after 20? Excellent! The next term after 20 is 25. And this is also an example of multiples of 5. What about the last set of numbers? 16, 8, 4, 2. What do you observe about this set of numbers? Yes, they are decreasing. Okay? Amazing! The next term is obtained by multiplying 1/2 to the previous term. Or shall we say, the number is divided by 2. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. Three, 7, 11, and 15, again, is an example of sequence. A sequence is an ordered arrangement of set of numbers. Each number in the sequence is called term. The next term is obtained by adding 4 to the previous term. 3 plus 4 equals 7. 7 plus 4 equals 11. 11 plus 4 equals 15. What comes next after 15? You're right. The answer is 19. Positive 4 is added from the previous term to get the succeeding term. This is called common difference and usually denoted by letter D. This set of numbers is an example of an arithmetic sequence. Here, there is a constant number added from the previous term. This constant number is called common difference. An arithmetic sequence is a sequence in which the difference between any two consecutive terms is a constant. We have 3, 7, 11, 15, and 19. What is the common difference? Yes, positive 4. So there are how many terms? Exactly, there are 5 terms. 3 is the first term. 7 is the second term. 11 is the third term. 15 is the fourth term. And the last term, or the end term, is 19. And they usually denoted by A sub 1, A sub 2, A sub 3, A sub 4, and A sub 8. What about A sub 8, or the 8th term? Yes, that is 31. Four, 9, 14, 19. Is it arithmetic sequence or not? Yes, it is an example of an arithmetic sequence. The common difference is 5. The sequence is called arithmetic sequence if the difference of any two consecutive terms is constant. This difference is called common difference. 2, 5, 8, 11. Is it an arithmetic sequence or not? Yes, it is, again, an example of arithmetic sequence. What is the common difference? Common difference, or denoted by a small letter D, is positive 3. 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11. Next, we have 15, 12, 9, and 6. What have you noticed to this set of numbers? Amazing! They are decreasing. If this is the case, this arithmetic sequence has a common difference which is negative, and that is negative 3. To find the common difference D, simply subtract the first term from the second term, the second term from the third term, and the third term from the fourth term. So 15 is represented by a sub 1, 12 is a sub 2, 9 is a sub 3, and 6 is a sub 4. So a sub 2 minus a sub 1 is 12 minus 15, which is negative 3. A sub 3 minus a sub 2 is 9 minus 12. Again, it is equivalent to negative 3. A sub 4 minus a sub 3 is equivalent to 6 minus 9, and it is also equivalent to negative 3. What about this set of numbers? Yes, this is an example of arithmetic sequence, and its common difference is negative 5. Observe that this example is a combination of positive and negative numbers. Don't be confused. Just simply subtract each pair of numbers from right to left. Let us take 8 and 3. Right minus left. That is negative 5. For the next pair, we have negative 2 minus 3. And that is also equivalent to negative 5. Always remember that in subtracting numbers, change the operation from subtraction to addition. To add integers with different sign, just subtract the smaller number from the larger number. Then keep the sign of the larger number. Hence, negative 12 plus 7 is equal to negative 5. Let us apply the concepts you have learned. Are you ready? First, what is the common difference? Yes, that is positive 7. So, notice that if you add positive 7 from the previous term, you will get positive 10. So, 3 plus 7 is 10, 10 plus 7 is 17, and so on and so forth. Number 2, what number should come after 59? So, 59 plus 7 is 66. Which is the sixth term of the sequence? The sixth term is 38. What is the 10th term of the sequence? Since 59 is the 9th term, hence the 10th term is positive 66. Which term of the sequence is 108? Good. The answer is 16th term. Notice that if you're going to add positive 7 from 59, you will get 66. 66 plus 7, 73, plus 7, 80, plus 7, 87, plus 7, 94, plus 7, 101, plus 7, 108. Okay, by counting, 59 is the 9th term, 10 term, 11 term, 12 term, 13 term, 14 term, 15 term. Therefore, 108 is the 16th term. Question? Good. Consider the arithmetic sequence 1, 3, 5, 7, and 9. For the first term is equal to 1, and the common difference is equal to 2. The second term is 3, and can be written as 1 plus 2. Replacing 1 by a sub 1 and 2 by the letter D, we have a sub 2 equals a sub 1 plus D. For the third term, 5 can be expressed as 1 plus 2 plus 2. For a sub 3 is equal to a sub 1 plus D plus D. Combining similar terms, we have a sub 3 equals a sub 1 plus 2D. For the fourth term, 7, it can be written as 1 plus 2 plus 2 plus 2. Or a sub 4 equals a sub 1 plus D plus D plus D, which is equal to 3D. Hence, a sub 4 is equal to a sub 1 plus 3D. Consider a sub 3 and a sub 4. What do you observe? That's right. A sub 1 is fixed, and the coefficient of D is 1 less than the order of the term. Hence, if we're looking for the nth term and using this pattern, we will have a sub n equals a sub 1 plus the quantity of n minus 1 times d. And this will serve as the formula or the general term of an arithmetic sequence. Where a sub 1 is the first term, n is the number of terms, and d is the common difference. For our given arithmetic sequence 1, 3, 5, 7, 9, the first term is 1, the number of terms is 5, and the common difference is 2. What is a sub n, or n is equal to 20? So using our formula, we just replace n by 20. So we'll come up at a sub 20 equals 1 plus 20 minus 1 times 2. 20 minus 1 is 19 times 2 is 38. 38 plus 1 is 39. Therefore, a sub 20 or the 20th term is 39. For us to find the 10th term of the given arithmetic sequence, again, from our previous example, the 10th term is 66. So using the general term for an arithmetic sequence, we have a sub 10 equals 3 plus the quantity of 10 minus 1 times 7. Since we're looking for the 10th term, so n is equal to 10, the common difference is 7, and the first term is 3. So 10 minus 1 is 9 times 7, we have 63, plus 3 equals 66. So therefore, the 10th term of the given arithmetic sequence is 66. Based from our previous example, we all know that 108 is the 16th term of the given arithmetic sequence. Now, let us prove that 108 is really the 16th term of the arithmetic sequence using the formula or the general rule of an arithmetic sequence. All we have to do is to plug in all the known values. So, a sub n is equal to 108, A sub 1 or the first term is 3 and D or the common difference is equal to 7. So plug in all the known values in the general rule. So we have 108 equals 3 plus the quantity of n minus 1 times 7. Using the multiplication property of equality or the distributive property of equality, we'll have 7n minus 7. Then combining similar terms, we have negative 7 plus 3, which is equal to negative 4. Using addition property of equality, we'll have 108 plus 4 is 112. To solve for n, divide both sides by 7. Cancel common terms, we have n equals 16. Hence, 108 is really the 16th term of the given arithmetic sequence. Another way of using the n term of the given arithmetic sequence 108 is using the general rule of an arithmetic sequence. Manipulating this formula, we will have n equals a sub n minus a sub 1 all over d plus 1. Replacing a sub n by 108, a sub 1 by 3, d equals 7. So we'll have n equals 108 minus 3 all over 7 plus 1. 108 minus 3 is equal to 105. 105 divided by 7 is 15. 15 plus 1 is equal to 16. Hence, 108 is really the 16th term of the given arithmetic sequence. Okay, this time we're going to find the n term of a particular arithmetic sequence. So we have again 1, 3, 5, 7, 9, wherein the common difference is d. So using the n term or the rule of an arithmetic sequence, just replace a sub 1 by 1 and the common difference by 2. Manipulating the equation, we have a sub n equals 1 plus 2n minus 2 using the distributive property of equality. Combining similar terms, we have a sub n equals 2n plus 1 minus 2. And 1 minus 2 is equal to negative 1. Therefore, a sub n is equal to 2n minus 1, which is the n term of the given arithmetic sequence. Using the process, we're going to find the n term of a given particular arithmetic sequence, wherein the common difference is 5, and all the terms are denoted by a sub 1, a sub 2, a sub 3, a sub 4, and so on and so forth. We're going to use still the general term for an arithmetic sequence. Just simply replace a sub 1 by 5 and the common difference by 5. Using the multiplication property of equality, we have 5n minus 5. Combining similar terms, we have 5n plus 5 minus 5, which is 0. So, therefore, the n term of 5, 10, 15, 20 is a sub n equals 5n. Okay, let us consider the third example. The first term is 24,000. The second term is 24,600. And the third term is 25,200, and so on and so forth. What do you think is the common difference? Amazing! Your answer is correct. The common difference is 600. How did you get 600? Yes, 24,600 minus 24,000 is equal to 600. Now, using the general rule or the general term for an arithmetic sequence, we just simply substitute or plug in all the known values. So, we'll have a sub n equals 24,000 plus the quantity of n minus 1 times 600. Using the distributive property of equality, we'll have 600n minus 600. And then combining 24,000 and negative 600, we will have 24,000 minus 600 is 23,400. Hence, the n term of this particular arithmetic sequence is a sub n equals 600n plus 23,400. There's another way of finding the n term of a particular arithmetic sequence. Do you want to know? Okay, let us start. Now, always remember to identify the pattern from the given sequence, and that is adding 7 to the previous term. Now, just simply affix 7 to n, and then subtract the common difference d from the first term. So, we have a sub 1 minus d is equal to negative 11 minus 7. Negative 11 minus 7 is negative 18. Hence, the n term of this particular sequence is a sub n equals 7n minus 18. Another example, if we have 5, 10, 15, 20. So, you still remember that our n term from the previous example is a sub n equals 5n. Now, again, the next term is obtained by adding 5 to the previous term. Hence, the common difference here is positive 5. So, just affix 5 to n. So, we have 5n. And then, using first term minus the common difference, we will have 5 minus 5, which is 0. Hence, the n term of this particular arithmetic sequence is a sub n equals 5n. Let's take another example. So, in this particular arithmetic sequence, the common difference is negative 2. So, hence, just write letter n beside negative 2. And then, subtract the common difference from the first term. So, we have negative 11 minus negative 2. Always remember that if the operation involved is subtraction, just simply proceed to addition but change the sign of the subtract. So, we have negative 11 plus 2. To add integers with different signs, just simply subtract the smaller number from the larger number, then keep the sign of the larger number. So, the sign of the larger number is negative, so we have negative 9. Hence, the n term of this particular sequence is a sub n equals negative 2n minus 1. Let's take another example. What you observe in this example? Good. This example is decreasing. Hence, the common difference is negative 3. Then just put letter n beside negative 3, so we have negative 3n. Now, a sub 1 minus d is 15 minus negative 3. Again, proceed to addition. So, the answer is positive 18. Therefore, the n term of this sequence is a sub n equals negative 3n plus 18. Okay, do you have any question? Okay, thank you. Now it's your turn. I know you can do it. Do the remaining exercises in your module for lesson 1. Bye-bye.